Last lecture, we discussed linear equations. These are equations where the variable has a highest power of 1. Now we will discuss equations that have a highest variable of 2. Those are called quadratic equations. We saw one method for solving quadratic equations. If we can factor the quadratic as a product of two linear polynomials, then we can set each factor equal to 0 and solve the linear equations. Sometimes it's very hard to factor, or sometimes we can't even find the factorization, and so it would be useful to have a formula for finding the solution to a quadratic. A quadratic has an x squared term, it has an x term, and it has an x free term. That's just a number. So in general, a quadratic looks like ax squared plus bx plus c, where a is not equal to 0, because otherwise there's no x squared term and it's no longer a quadratic. For example, 4x squared plus 4x minus 2 is a quadratic. A is 4 because that is the coefficient of the x squared variable, b is also 4 because that's the coefficient of the x variable, and c is negative 2, that's the constant, that's the number. Or for example, x to the second power minus 3 is also a quadratic. Here, a equals 1, because there's no coefficient of the x squared, so it's considered 1. b is 0, since the middle term is missing. And c is negative 3. That's the constant. The first step to solving a quadratic equation is to bring it into the form of ax squared plus bx plus c, by moving the necessary terms over to the other side. We want 0 on the other side. So we want our equation to look like ax squared plus bx plus c equals 0. One side of the equation is 0, and the other is the quadratic in the form of ax squared plus bx plus c. For example, consider the equation x squared plus x equals 1. To bring this equation into the above form, subtract 1 from both sides. X squared plus x minus 1 equals 1 minus 1. So in essence, what you're left with is x squared plus x minus 1 equals 0. Now the quadratic equation has a quadratic polynomial on the left side and 0 on the right side. Another example. Consider the equation 3x squared equals negative 4x plus 5. To bring this equation into the form, we add 4x to both sides and subtract 5 from both sides. So we end up with 3x squared plus 4x minus 5 equals 0. Let's look at another example. Consider the equation 2x times x plus 1 equals 3. Open the parentheses with the distributive property to get 2x squared plus 2x equals 3. Now subtract 3 from both sides to get the equation 2x squared plus 2x minus 3 equals 0. When the quadratic equation has been rewritten, where one side is equal to 0, we can use the quadratic formula. It says that the solution to the equation are given by negative b plus or minus the square root of b squared minus 4ac all over 2a, and negative of the same. In other words, negative b minus the square root of b squared minus 4ac all over 2a. Essentially, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. This formula might look complicated, but it's pretty simple, as we'll see in some examples. All we have to do is substitute a, b, and c into this formula to get the answer. Now there are going to be two answers, one with negative b plus the square root of b squared minus 4ac all over 2a, and the other with the minus sign on top, negative b minus the square root of b squared minus 4ac all over 2a. In general, quadratic equations tend to have two solutions, although that's not always the case. Let's look at an example. Solve x squared minus 5x plus 6 equals 0. Here, a equals 1, which is the coefficient in front of the x squared, because there is no coefficient. B is negative 5, since that's the coefficient of the x, and c equals 6, because that's the constant. By the formula, there are two solutions. One formula is given by negative 5 plus negative 5 squared minus 4 times 1 times 6 divided by 2 times 1, which, if you solve it, if you break it down, equals 5 plus the square root of 25 minus 24 divided by 2, which is the same as 5 plus the square root of 1 over 2, which is 5 plus 1 over 2, which is 6 over 2, which is 3. And the other solution is setting it up the same, except now it's negative 5 minus the square root of negative 5 squared minus 4 times 1 times 6 divided by 2 times 1, which eventually comes down to 5 minus the square root of 25 minus 24 divided by 2 equals 5 minus the square root of 1 divided by 2 equals 5 minus 1 divided by 2 equals 4 over 2 equals 2. Therefore, the two solutions are x equals 2 and x equals 3. These are the two solutions, and you can check that by substituting into the equation and confirm that they will both work. Let's look at another example. Let's solve 2x squared plus 5x plus 1 equals 0. Here, a is 2, b is 5, and c is 1, because those are their respective coefficients. By the formula, there are two solutions. One is given by negative 5 plus 5 squared minus 4 times 2 times 1 all divided by 4. And that eventually moves down to negative 5 plus the square root of 17 divided by 4. The other solution is the same except with a minus sign. Negative 5 minus the square root of 5 squared minus 4 times 2 times 1 all divided by 4. And that comes eventually to negative 5 minus the square root of 17 divided by 4. We can't really simplify these any further. We can approximate the answers by writing the square root of 17 up to a few decimal places, since it's an irrational number, and then we can get the two answers in terms of decimals. This example illustrates why this formula is so useful. That example we just did with the square root of 17 is very messy. Factoring would be extremely difficult here, if not impossible, but a formula makes it easy. Let's look at another few examples. Solve 5x plus 2x squared plus 1 equals 0. It would be a common mistake to take a equals 5, b equals 2, and c equals 1. Remember that the coefficient on x squared is a. b is on the x, and c is the x-free number. So in this case, a would be 2, because that's the coefficient of the x squared, b would be 5, because that's the coefficient of the x, and c would be 1, that's the constant. From here, the solution would be just to plug it in and solve it like we did above in the equation. Let's look at another example. Solve 2x squared minus 1 equals x times x plus 2. The equation is not yet in standard form. We have to first expand it to make it 2x squared minus 1 equals x squared plus 2x. Then we can subtract x squared from both sides and 2x from both sides in order to get 0 on the right and all the rest of the terms on the left. Subtracting x squared from 2x squared gets you x squared. Subtracting 2x from no x term on the left side gets you negative 2x, and the negative 1 is still there. So it turns out that the equation is x squared minus 2x minus 1 equals 0. For purposes of the formula, a would be 1, b would be negative 2, and c would be negative 1, and from there we proceed to just plug in the numbers to the formula. In using the quadratic formula, we usually get two solutions to the equation, but sometimes we only get one solution. Sometimes we get no solutions at all. Consider the following two equations. Let's start with x squared minus 2x plus 1 equals 0. If we use the quadratic formula, a would be 1, b would be negative 2, and c would be 1, we find that one solution would be negative 2 minus the square root of negative 2 squared minus 4 times 1 all over 2. That eventually goes to 2 minus the square root of 0 divided by 2, which is 2 minus 0 divided by 2, which is of course 2 divided by 2, and thus 1. If we use the plus, we get the same answer. The square root term is 0 either way, so whether you do 2 plus the square root of 0 or 2 minus the square root of 0, it's going to be 0 either way, and the final answer is going to be 1 either way. We're getting the same answer to both solutions. This is because the equation x squared minus 2x plus 1 has only one solution to it, x equals 1, and no other solution. Indeed, it's also possible to factor x squared minus 2x plus 1 as x minus 1 times x minus 1 equals 0. And so, because the equation x minus 1 times x minus 1 equals 0, we set both sides as x minus 1 equal to 0, and the answer would be x equals 1 in both cases, which means that x equals 1 is our sole solution. So to reiterate, when we have a quadratic equation, ax squared plus bx plus c equals 0, the two solutions are given by negative b plus the square root of b squared minus 4ac all over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. These fractions look basically the same, except that one has a positive and one has a negative in front of the radical, the square root of b squared minus 4ac. The name of the number inside the radical, b squared minus 4ac, is called the discriminant. It provides valuable information about many solutions that a quadratic has. In the above examples, b squared minus 4ac was above 0, and we thus ended up getting two solutions, one by taking the positive square root of b squared minus 4ac, and the other by taking the negative square root of b squared minus 4ac. In the immediately previous example that we did, we had a b squared minus 4ac equals 0. Then the discriminant was equal to 0. In this case, the two solutions to the quadratic formula are the same, because the square root of 0 equals 0, and whether you add 0 or subtract 0 is not actually going to change anything. The last case is where the discriminant b squared minus 4ac is negative. In this case, there are no solutions, because there are no square roots of negative numbers. Suppose that b squared minus 4ac is negative 4, a negative number. What is the square root of negative 4? We might be initially tempted to say negative 2, but that's wrong, since negative 2 squared is actually 4, not negative 4. Whenever we square a non-zero number, we also get a positive outcome. We never get a negative outcome. Since there are no square roots of negative numbers, it means we cannot find a square root. Thus, in this case, the quadratic has no solution. Now, you may recall the concept of I, or an imaginary number. That is the idea that the square root of negative 4 can be written as 2i, I being the square root of negative 1. It's an imaginary number, but it can still be quantified and written. Therefore, if the discriminant is negative, the solution to a quadratic would involve imaginary numbers. But in this course, we're not going to deal with imaginary numbers. We'll say that there are no solutions to the quadratic when the discriminant is negative, even though it would be more precise to say that there are no real solution. Let's summarize. If the discriminant, b squared minus 4ac, is positive, there are going to be two solutions. If the discriminant, b squared minus 4ac, is 0, the quadratic will have one solution. If it's less than 0, the quadratic equation has no real solutions. Let's look at an example. How many solutions does 2x squared minus x plus 4 equals 0 have? Here, a is 2, b is negative 1, and c equals 4. We don't actually have to do the entire quadratic equation, we just have to look at b squared minus 4ac, which is negative 1 squared minus 4 times 2, which is 1 minus 32, which is negative 31. Since the discriminant is less than 0, the quadratic equation has no solutions. Once we understand how to solve quadratic equations, we can even consider word problems that lead to quadratic equations. Let's look at an example that involves a little geometry. Let's say a rectangle has a longer side that is 4 feet longer than the shorter side. The area of a triangle is 140 square feet. Find the dimensions of the rectangle. Now, the way we solve this problem is by letting x be the length of the shorter side, and the longer side is x plus 4. The area of a rectangle, again, whether you've learned it or not, is the product of the width and the height. So the area of the rectangle would be x times x plus 4. The x is a variable, because when we substitute a number for it in x times x plus 4, we get the area of the rectangle, where the shorter side is x. We are told that the area in this case is 140 square feet. Therefore, we need to find an x such that x times x plus 4 equals 140. So we can solve the equation, or we can set up the equation, x times x plus 4 equals 140, and when we open the parentheses, we get x squared plus 4x equals 140. Then we can subtract 140 from both sides to get it into the form that we need, and the form would be x squared plus 4x minus 140 equals 0. Now this is a quadratic equation written in proper form. A is 1, b is 4, and c is negative 140. Applying the formula, we get negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 140. When we multiply that out a bit, we get negative 4 plus or minus the square root of 16 plus 560, all divided by 2, or negative 4 plus or minus the square root of 576 divided by 2. Square root of 576 is 24, so we've got two solutions. Negative 4 plus 24 divided by 2, and negative 4 minus 24 divided by 2. In negative 4 plus 24 divided by 2, that turns out to be 20 divided by 2, which is positive 10. And negative 4 minus 24 divided by 2 is negative 28 divided by 2, which is negative 14. So we've got two values for x. Negative 14 and positive 10 are both solutions. Clearly, negative 14 cannot be the length of a side of a rectangle, as it's a negative number. So we reject this answer. You cannot have a negative length, which means that x equals 10 is the only solution, and therefore that is the length of the shorter side. The longer side then becomes 14 because the longer side was x plus 4. And these are the dimensions of the triangle. If you multiply it out, 10 times 14, you will see that in fact the area is 140. Beginning with the next class, we will look at the Cartesian plane. It allows us to study equations visually.